Today I'm going to replace the 3D printed frame for my pellet maker, which had some issues, with one that I CNC mill out of plate aluminum. Welcome to another episode. So in the last episode about my pellet maker, I had some problems with the frame that I printed delaminating, and I decided to finally create a aluminum version that I CNC mill out of some plate aluminum. So let's head to the workshop and I'll start milling out the parts. For this job I need to add a couple more tools, which is a tap, the 1024 tap, and a number 26 drill. And so it turns out the sizes that I need are already in use. So I took these two drills out of the machine, and what I'm going to do now is undo these so I can reuse the collets. So that collet I can use for the tap. And for this tap, I'm going to use the torque wrench so that I can tighten it to the correct torque. Okay, and that will ensure that that doesn't slip. For the drill, I don't need it to be that tight, because it's not going to have the same force. And I may not have needed it that tight for the tap, but I'd rather not have it slip since this is the first time I'm using a tap. And I'm just hand tightening this rather than using the torque wrench. Okay, the next thing to do is put this in these two in the machine and set the tool length, and then I'll be able to start this job. So first thing I want to do is get out my tool to measure the height. This is precisely 4 inches tall. So then I'm going to put in the first tool, which according to my cheat sheet is tool 14, and that's the tap. So I'm going to go over here to hand jog, tool 14, and then that'll move to that spot. Oh, I already have something in tool 14. Okay, so I'm going to have to change this to 15 and 16. So I'll just do ATC forward. So I have 15 as the drill. I'll put this in here and press tool release. Okay, and then I can bring it over to measure the height. Let me move this over a little bit because it was hitting the okay, and then I'll position this. Switch to 1/10. Okay, and then I can go to tool measure offset. Just make sure that's set to 0. So this says minus 8.7. Now it's minus 2.3, so that looks good. So then I'll say ATC, sorry, next tool. And that's tool 16 now, so I'll put the tap in tool 16. And then bring that down as well. I'll do Okay. So now I have the tools measured. As I say, I need to go in and update the CAM so that I have tool 16 as the tap instead of tool 14. As I mentioned, I had the tap at tool 14, and what I need to do is edit that tool and change it to tool 16. And then go ahead and repost all of these. And I can put this back in here and go and select the first program. So list programs, USB drive, pelletizer, and then I'm going to do main first, and I'm all set to go. Now on here, I've already set up the block in here, so I just need to pick up the left side because I already have the back and the bottom from before. So I'm going to go ahead and change the tool to the hand jog to the Heimer. And as I said, I just need to pick up the left side. Go to offset G54X and then part 0. And now I'll just back off. And then I'm going to raise the Z. Pull it out. Put the tap back in. And now I'm ready to start. But first I want to set up my camera here, which is what I'll use to film what's happening in there. I've started to set the width and cam of the stock to be a little bit wider than the actual part so I can mill it to the exact width that I want. I'm using a 3/16 inch diameter Aluma-Power end mill to pocket out the hole, which is the only feature in the first op. I'm being fairly conservative running this. I'm only making a few parts, so I'm not too worried about hogging out as much metal as I could. Here I'm about to cut all the way through, and you can see that the water is pouring through all the way. And then finally this is doing a finishing pass, the contour with an extra finishing pass. So let's see how the bearing fits in. Okay, so the bearing is a little tight. Let me deburr this corner, the edge. I think I set this so that it's exactly the same as the bearing. All right, let's see what's going on here. Here's the bearing that I want to fit in. And if I measure it, you can see it comes out to pretty much 0.875. Very close to 0.875, which is the dimension that I put into CAM. And I thought I put in a little bit extra, but let's have a look. So let me put the snap gauge in here. And let's see what that measures at. So 0.875 pretty much. Okay, let's have a look here. This is the sketch right here. And it's 0.875. Okay, so what I need to do is I'm going to add 2 thousandths, which should give us a nice fit. I do not want it to be a press fit. I want it to be a light fit, so it's easy to take the bearings in and out, because I need to be able to do that to easily take the cutter in and out. And let's give that a try. Okay, that's perfect. There's a tiny bit of wiggle, but I'm happy with that. So now I'm going to set it up for the next position. Okay, so what I've got here on this cheat sheet is it says that this circle here needs to go down like that. And then the offset is going to be the back left. So it'll drill 2 holes in there. So I'll go ahead and get that set up. Okay, so that's X0, or I should say the left side of the part. Now we'll do Y. And what I'm going to do for Y is I'm actually going to bring it in front of it, and that way I can do a trial run without actually touching anything. So I'll bring it back up, and then what I'm going to do is I'll set the Y0 correctly once I'm okay with the tool path. So first it's going to spot drill. Okay, that's the right height. And then it's going to drill. I just realized something. So for tool 15 and 16, I forgot to subtract 4 inches because the height of the zeroing tool is 4 inches. So I went here and I'm going to type -4 dot. Right now it says -5, and then I'll press right. And now it says -9. So that'll move it down by 4 inches. And then the same thing for 16, -4 dot, right enter, yes, and that went down as well. So let me go back and run the program. And this is starting from the beginning, which is fine. Okay, as I say, now it's going to switch to the drill. Okay, that looks good. And then it's going to do the rigid tapping, which I've never done on this machine before. Oh no, it's going to do a chamfer first to give a lead-in for the tap. And now it's going to do the rigid tap, so let's see what happens. That looks good. Okay, what I'm going to do now is set up the Y. First I'm going to redirect the coolant the way I want. So I'm going to set up the Y to make sure it's correct, and then I'll give it a try. That is so nice. Okay, easy peasy. Okay, so now I'll take a look at my setup sheet. again. And so it has the screws on this side, and so it's like this. Now to do a quick deburr of the backside. And then of this one. Okay. That turned out really nice. Oh, I feel a sharp edge here. Okay. It turned out really nice. Okay, let's see what happened here. If I take a look at the operations, that looks good. Yep, we went through that. Ooh, I missed these right here. So that's what's causing the issue. All right, so let me redo this. I'll edit this. And I wanted it to have it on inside boundary, I think. Not quite. Inside. Oh, I see. I had additional offset. That was the issue. Okay. Now that's what I expected. Okay. Well, I don't need to redo that, so I'll just repost the other operations and then head back to the mill. So this next step is not something that's really required, but I'd like to have a nicer finish than the raw finish of the material as it came. So I'm going to put a little bit of WD-40 on this 220 grit sandpaper, and I'm putting the WD-40 on here so, to use it as wet dry sandpaper. So what will happen is, instead of clogging up the sandpaper, the dust basically collects here, and then I can just mop it up pretty easily with a shop towel. So it's a little hard to see how that's doing, but if I clean it off, you can see that already it's getting a nicer brushed finish to it. So compared to this side, see if I can get you a better view. So compared to this side here, this definitely looks nicer. And so then I'll try the other side. And I'm just sanding in one way to give it that brushed look. And I'm going to sand this a little bit more because there are some other marks, so I want to get rid of those. But I'm liking how this is working. You can see that I get some of the aluminum dust picking up pretty quickly. And as I mentioned, I can just blot that off with a shop towel. And you can see how easily that picks up the aluminum dust and basically clears out the sandpaper. So now I can just put some more WD-40 on here and continue sanding. And again, it builds up very, very quickly. So I'm going back and forth between cleaning this off to see how I'm doing. And that's coming along nicely. It's a lot nicer than it was before. In fact, that's probably plenty fine. And then just blot this up again. And I'm ready to start on the next piece. And by the way, this is a cheap grade B surface plate that I bought from Shars, and I think it was like $50. So I just wanted something flat and something that I didn't have to worry about, and not use my good grade A surface plate. Okay, I think these look nicer, and so now I'm going to put away my surface plate and start to assemble this. Before I made this out of aluminum, I did a version that was made out of 3D printed parts just so that I could make sure that everything worked the way I wanted it to, and it does. So what I'm going to do is disassemble this. This is what I'm taking off right now is a shield, and I'll explain that as soon as I finish taking it off. But basically the purpose of this is to keep the plastic pellets from flying all over the place, because they had a tendency of doing that before. So this design is not the final design, but this is where the cutter is. And so the pellets would fly here and then come down. And in the final version, as you'll see, I have yet another baffle. And so that slows the pellets down a lot before it hits the container. Anyway, so I'm going to, as I say, disassemble this and then reassemble it as the aluminum version. Okay, I'm going to take this off in a little bit. But what this will also do is remind me of how this goes together. So looking here, I can see that this is this block here. And then this goes like so on top there. So I'll grab one of the bolts. These are 1024 by 3/4 because that's what I had in my toolbox. Oop, wrong hole. Goes into this one right here. I'm not going to tighten these down completely until I have it all assembled. Okay, so then the next one goes like so. Then this goes on the back. So like so. Let me figure this out. Okay. There we go. So that's like this, and then this goes like this. Okay. So that means those holes will line up. Okay, those all feel like they're pretty much lined up, so I'll start to tighten these down. And later on, once I validate that everything is okay, then I'll come back and I'll add some Loctite to these screws so that they don't go anywhere. Oops, I forgot a detail, which is, we'll find out. We'll see if I can put the stepper motor on once it's already on here. So I also need to get, let's see, unscrew this. Okay, and then this will go in like so. And I'll tighten this down in a little minute. The bearings go in like so, but what I'm going to do is put the stepper motor on first before I put the bearings in. So I'll take that out, and then disconnect the stepper from here. Okay, so this one should go on like so. So I'll grab these screws. And they're a little bit tighter on the 3D printed version, which is pretty common for these to be tighter when you 3D print it, because the holes kind of tighten up and the outsides move out a little bit. Okay, so I'll put the first couple in here. I think I need about 3 hands now. Okay, now what I want to do is line these two up. It looks like it's pretty well lined up. Actually, what I'll do is I can look straight through here. I'm looking through here. Okay, and that's centered. I verified that. And so now I'll go ahead and tighten these down the final way. All right, that's back together with the aluminum version, and then one of these goes here, the other one goes here, and then this goes back on like so. And then this is a retainer. It's just a 3D printed retainer that has a little boss. What I really need is probably to make a piece with a lathe. And then what I want to do is adjust this so that it's just has minimal gap. I think that's about as close as I want to get it. So what I'm going to do is get a couple of wrenches and tighten that down. Maybe a little closer. Yeah, that's good. And I'll probably want to put some Loctite on that as well at some point. See, I don't have another wrench of the correct size. Okay. That should hold it in place. Here's the final shield. You can see I added this. This is going to be right in here. So what this will do is prevent the pellets from shooting out the side here. They'll have to go down. So this just mounts on here like this with a couple of 440 screws. So the pellets will come out down here. And so what I'm going to do is mount this back up on the board and then fire it up. I've now run 2 rolls of filament through this new frame, and I don't expect to have any problems. I mean, it's not going to break. So I'm really happy with the frame right now. There are a few things that I want to improve, like I'd like to replace the 3D printed funnel that funnels the filament into the bolt with something that's made out of metal. And then there's the stop that is on the cutter, between the cutter and the chuck of the electric drill, that I'd like to replace as well. I could order something for that, but I'm going to see if I can, in a future episode, replace it with a piece of aluminum. I hope you enjoyed this episode. Give me a thumbs up, subscribe, comment below, and I'll see you next time.